Hi and welcome back. In this video we will learn how to take user input and use it in a program. I will also demonstrate a feature of the printf function that hasn't been explicitly covered in the previous videos. In addition to that, we will practice using arithmetic operators to do calculation, including calculation with numbers that can have a fractional part. More importantly, we will cover all that while creating a program that is slightly more useful than anything we made in the previous videos. We have a lot to do, so let's get started. Up until now, the programs that we made were not interactive, meaning they were not able to respond to user input, which didn't make them very useful for purposes other than educational. Let me show you what exactly I'm talking about. If you want to, say, add 1 and 2 and output the result, you will need to write a program like this. And if you want to change one or both numbers, you will need to change the code, which isn't the best practice. For example, if we look at calculator apps, they do all the math with the numbers that you provide. You don't need to modify the code. So what we're going to do now is we're going to make a more interactive program that responds to user input. Let's start off with a simple example. We're going to create a program that takes the text that you type in the console area and prints it back. Not super useful, but just right to introduce the function that can do something like that. First of all, to be able to do something with user input, we need to store it somewhere. For this purpose, we're going to use what? Right, a variable. Since we want to store text, and ideally text that consists of more than one character, we need to declare a string of characters. Let's name it S, and let's set its size to 50 characters, just in case. To get user input and store it in the variable S, we will use the scanf function. Not only does scanf sound like printf, but the scanf function also works similarly. To have the scanf function do what we want to do, we need to tell it what we want the input data to be interpreted as, which in our case is text, and where we want the data to be stored, in our case in the variable S. Now, if we run the program, it will allow us to type something in the console, but it doesn't do anything with our input yet. Let's have our program print out input back at us. And now, if you type something in the console and press the return or enter key on the keyboard, it will repeat what we say. Let's make it slightly more interactive by having our program add some more text before it repeats what we say. Note this space after the word said. If we don't add it, the two outputs will get jammed together. Let's make it even more interactive by having our program add some more text after it repeats what we say. Let's add a smiley. Looks better now, but can be even better. We can actually avoid calling the printf function 3 times, and here's how. This part that in the previous videos I referred to as a special instruction that tells the computer how to display the data is called parameter, while the whole thing inside the double quotation marks is called parameterized or formatted string. Formatted strings allow you to introduce values of variables in an otherwise standard string that consists of characters only. A formatted string can contain multiple parameters. For example, if we want our program to repeat what we say twice, we can add another parameter. But we will also need to specify the value of which variable must be displayed. If this is too confusing, I recommend that you pause the video, look at the code again, and try to see the logic behind it. I'm sure if you do so, it will get less confusing. Ready to move on to the next part? In this part of the video, we're not going to need the code we wrote before, so I'm going to erase it. The program we're going to create now will do simple math with 2 numbers that you provide. To store the input, let's declare 2 variables of the type int and name them num1 and num2. Before having our program take user input, let's make it a bit more friendly by having it communicate with the user. Let's make it greet the user and tell the user what he or she is expected to do. If you don't know or don't remember what this backslash followed by the letter n does, you can refer to the previous video. Now let's take the first number using the scanf function. There's one detail. To make the scanf function read user input as a number, we need to add the ampersand symbol immediately before the name of the variable we want to store the input in. This effectively tells the scanf function where in computer memory the value of the variable is located. For now, to avoid untimely complexity, let's just take it for granted without trying to understand why it is the way it is. Let's repeat these two actions for the second number. Now we have two integer numbers obtained from the user, and we can finally do math with them and output the result. It works, but as usual, it can be better. The way it is, you don't really know what the number the program prints means if you don't see the code. Let's make the output more informative by using a formatted string with three parameters. The first two for the numbers obtained from the user, and the third one for the sum of those numbers. Pause the video if you need to make sure you understand what's happening here. Now let's do the same for subtraction, multiplication, division, and I mentioned in the previous video that there is a fifth arithmetic operator in programming. You can see it on the screen. What it does is it calculates the remainder of integer division. For example, if you divide 4 by 3, the remainder will be 1, meaning if you have 4 apples and you need to equally distribute them among 3 people without cutting a single apple into pieces, each of the 3 will get 1 apple, and 1 will be left. Now let's run the program and input, say, 10 and 5. The math looks right. Now let's run the program again and input, say, 15 and 10. Still looks fine except for division. While 15 over 10 should be 1.5, the program prints 1. This happens because there are two types of division in programming, integer division and floating point division. Since both numbers that we do math with are integers, the program applies the integer division, and the result of the integer division is an integer number, meaning a number without a fractional part. To enable our program to handle numbers with a fractional part, we need to use a data type other than int. In programming, a number with a fractional part is called a floating point number, and to store a floating point number, we can use the type float. Let's change the data type of the num1 and num2 variables to float. Since num1 and num2 are float variables now, we need to make respective changes in the scanf and printf functions to handle the variables correctly. Unfortunately, since the remainder operator doesn't work with floating point numbers, we will have to say goodbye to it. There's a way to keep it, but to keep it simple, we're not going to go there in this video. And now our program correctly divides the numbers. Wow, it was a lot of content, so if you feel overwhelmed, there is nothing to be ashamed of. Let me summarize what we've covered in this video. To take input the user provides using the keyboard, we can use the scanf function, which is pretty similar to the printf function. Both printf and scanf deal with the so-called formatted strings that can contain values of variables. There are two types of division in programming, integer division and floating point division. The result of an integer division is an integer number, a number without a fractional part. The result of a floating point division is a floating point number, a number that can have a fractional part. To store floating point numbers, we can use variables of the type float. I hope you remember that computers process data. So far, we've covered the following processing operations: data input and output using the scanf and printf functions, data storage using variables, and arithmetic operations with numbers. In the next video, we'll talk about another data processing operation, evaluation or comparison. Hope to see you then. Bye.